In this section, we will explore the specific structures. You have completed the first part, clearing the land, excavating the building site, and constructing the footers and slabs. In this section, we will examine 3 different structures: full basements, split levels, slabs, and crawl spaces, starting from the footers and slabs. For now, let's stay with the full basement. For subterranean termites, the full basement construction from the ground up is a beacon for termites. The following slides will shed light on the reason why. We left the last course with a big hole in the ground. The structure footers are in place, and the walls and slab are complete. The problem with full basement construction is that the walls are not strong enough to support the backfill material without the first floor decking and some of the initial house framing in place. The pressure of the backfill without the decking installed would blow out the walls. Therefore, carpenter crews descend on the site, bringing in massive amounts of wood to build the framing. During that construction, large quantities of wood debris and other trash are scattered in and around the crater. To support the front stoop, which is always the culprit for termites, the cantilevers support arms from the wall on which the front stoop will rest. This prevents the front stoop from settling and breaking away from the structure. The reason the front stoop is so notorious for termite activity is that while the first floor deck and first floor framing are being constructed, all the wood debris is swept out the front door at the front stoop, directly into the open cavity. Now think about it, what do termites feed on? Correcto mundo, wood. So what the workers are doing is loading the cavity that will soon be backfilled with a food supply for termites, wood. Of course, this will draw termites, and of course, the front stoop and door frame are primary targets. Now you have a better understanding of why new construction, especially full basement construction, is so conducive to subterranean termite invasion. Always be suspicious of the front stoop when inspecting and treating these types of homes. As we enter phase 2 of basic structures, I want to emphasize that in full basement construction, the plumbing, sanitary systems, and water pipes are often suspended, meaning they come in just below ground level and not as frequently from the slab. Before starting any termite treatment, always locate the water cutoff valve where it enters the house in case of an accidental waterline strike.
Next, we move on to the next type of structure you will encounter: the crawl space. Crawl spaces can be creepy and often unpleasant areas that are rarely visited, unless you are a rodent, insect, or wildlife. For these creatures, the crawl space is ideal since it is seldom disturbed. As a termite inspector, you are required to frequently visit and inspect them for infestations and damage. Some crawl spaces are well kept and easy to inspect, while others can be not only unpleasant, but also too dangerous to enter. During the WDI inspection training, you were taught how to identify crawl space issues. For now, let's stick with the basic construction. Crawl space construction is similar to basement construction. First, the topsoil is removed, but rather than excavating to the full depth of a basement, the excavation is only half that or even less. Footers are then placed using poured concrete with steel bars installed within the concrete to support the walls of the structure. Even today, in most cases, crawl space construction walls are made of hollow blocks. This presents an issue with subterranean termites. Termites can enter the hollow blocks and navigate up the inside voids, going unseen and attacking the sill plate and band boards, advancing up into the home's inner walls. In many cases, to treat this problem, a treatment procedure called wall voiding is required to introduce the termiticide to the termites inside the hollow voids. You can usually identify structures with crawl spaces by their crawl space vents. Additionally, entry points can be challenging to find. They may consist of drop-down hatches on the interior floor or on the sides of the crawl space walls, and in many cases, they are located in exterior window wells. Another important factor in the diagnosis and treatment of crawl spaces is the presence of piers. Concrete piers are typically dug and poured into the crawl space ground, usually down the center. These piers support blocks that extend upwards to support the main beam of the house. Technicians often neglect to treat the area around the piers during treatment, and untreated termites can cause significant damage, as the lack of treatment around the piers fails to address the termite infestation. Although excavation has decreased, There are still backfill issues with trash and wood debris from the carpenters and the frame construction that will attract termites to the structure. As is the case in full basements, crawl space plumbing and pipe chases are normally hung coming in above the crawl floor. Also, insulation is hung between the floor joists, making inspections difficult and often hiding activity and damage from pests. So let's look at slab construction. As we have seen how the full basement is submerged into the ground, and the crawl space, a step-up slab construction you would think would be the easiest to treat and control for subterranean termites since it sits almost literally at ground level. However, slab construction is the most difficult when it comes to treating and controlling subterranean termites. As is the others, the topsoil is pushed off, and the only excavation is for the footers almost at ground level. The plumbing is brought in at ground level, just under the concrete slab floor. Water lines, electrical, and even gas lines are brought into the structure and laid just below the concrete slab. Again, it is bearing soil, 4 inches of gravel in most cases, a poly-moisture barrier, and the pipes extend up with the concrete for the floor poured around them. In many cases, even the heating duct system is placed, and the concrete is poured around them for the floor. Navigating a versatile and drilling around those obstacles is a challenge when performing a subslab injection treatment for termites. Subterranean termites easily push up around the pipe chases through the floors into the inner walls, often unnoticed. They use the water lines as well as the heating ducts. Treatment with subslab drilling and injection is extremely risky. The risk of hitting water lines, electrical, and even gas lines can be catastrophic. For that reason, slab construction is the most risky of all of these. To complicate matters, many homes feature mixed elevations. It is not unusual to encounter combinations, such as a crawl space with slab construction or slab with a full basement. These configurations can pose challenges when diagnosing or addressing subterranean termite issues.
Now that we have taken a quick look at the different types of structures, let's go over what we might deal with regarding subterranean termites. On review, we all know carpenters are not very tidy. As a matter of fact, they are one of the reasons termites are attracted to homes. They chum the soil by covering up all the wood debris in the backfill, especially at the front door under the stoop. So we know termites must have a food source, wood. We also know they must have moisture, so where do the downspouts deposit the water? You guessed it, right along the side of the house where the wood is buried.
We also learned that despite what people may think, slab construction is the most vulnerable to subterranean termites and poses significant risks to the company. Since the plumbing, heating, gas lines, and electrical systems are all embedded in the concrete slab, drilling and sub-slab injections could potentially contact or damage any of these utilities. The consequences could be catastrophic.
Knowing where the water shutoff valve is critical and mandatory before drilling any interior slab areas. Always check the heating system and identify what type it is. Duct and slab, radiant heat, hot water pipe radiators. This has to be recorded on the treatment graph. Mistakes could be fatal. Injury is not only an issue, but if you drill through the slab and unknowingly penetrate an air duct while pumping liquid termiticide through the system, it may become impossible to correct the problem. As an inspector or a technician, you have to identify the heating system on any treatment recommendation. For that reason, you have to be familiar with equipment and signs that help you identify the systems. Recognizing the elements of these systems, especially on slab foundations, is critical. So let's take a look at a sample situation, one that is not unusual in a slab construction home with termites. As a technician or inspector, you are to provide a treatment plan, or worse, to treat this home for subterranean termites. Evidence of termites is obvious and active in several rooms, as pointed out on the slide. You also notice the vents in the floor and recognize that this is a sub-slab duct heating system. It is clear that treatment will require drilling and injecting product beneath the slab. So, how do you approach this without knowing where the duct system runs? From your training, you have learned that the duct system is installed before the slab floor, and to complicate matters, there are several patterns a sub-slab duct system can take. Knowing exactly where to drill could be nearly impossible. However, there is a solution. First, whenever you need to drill and treat a slab with that heating system, ensure a manager is physically on site to assist. Second, before you start drilling, do two things. First, locate the water shutoff valve in case you hit a water line. Second, use the mirror and flashlight technique to determine the direction of the duct system in the area you are preparing to drill on each length of drilling. Here is a great tool that will help you determine the direction of the ducts in the areas you intend to drill and treat. Locate the heating vent on the floor and remove the register. They normally lift up without any problems. Insert your mechanic's mirror into the cavity and shine your light directly into the mirror. The mirror will reflect the light back down the duct. Once the duct is lit up, you can look into the mirror and see what direction the duct in that area is going. It's not a perfect system. However, it will give you a safe idea for those short runs.
Alert! This is one of the most deadly mistakes.
That's 100% correct, my friend, and it happens more than you think. We all know that the front stoop area below the slab is a favorite nesting site for subterranean termites. Most labels require the stoop to be drilled and a chemical product pumped into the soil under it. However, in some houses, there is a room beneath the front stoop. So, if you drill the stoop and pump the product, you are pumping gallons of chemical into the room. This is a lawsuit and, at minimum, a costly repair operation at that point, not to mention a state violation. Anytime you are instructed to drill an exterior slab area, front stoop, patio, or carport, it is mandatory that another technician be inside the house in that area to ensure this does not happen. No exceptions. This does not apply to slab houses and crawl spaces, as those should be available for entry. This only applies to full basement structures. If there is no way to enter the structure, treat the full exterior, do not drill the slab areas, and record that on the service ticket as well as notify the manager. This case is even more common. It is what we call indented stoops. You will recognize these as they appear to indent inside the basic footprint of the structure when, in fact, they do not. Part of the front stoop is over a full basement, either finished or unfinished. If you drill these stoops, you will pump the product into the house. It is both the inspector's and the technician's job to ensure that nothing is beneath the exterior slab areas intended for treatment by subslab injection. It is also not unheard of for garages to have rooms under them, so the same principle applies. One of the main products we use to treat for subterranean termites is imidacloprid. This product is an insecticide that was made to mimic nicotine. Nicotine is naturally found in many plants, including tobacco, and is toxic to insects. Imidacloprid is used to control sucking insects, termites, some soil insects, and fleas on pets. It has been used in products sold in the United States since 1994. One of the advantages of this product is its systemic properties when used as an agricultural pesticide. For subsoil injections, the chemistry is not extremely stable. It tends to move in the soil, which is referred to as lateral soil movement, or LSM. This creates an overlapping treatment zone that is beneficial for termite treatments. However, the downside is that the LSM can contact herbs and plants we consume. Because it is systemic, the product could leach into the plants we use for food, which constitutes a violation and contamination of the food source. For this reason, you cannot use this product near any herbs or plants intended for consumption. Those areas, such as gardens, must be clearly identified on the treatment graph and avoided. Now, while we are on the subject of what could possibly go wrong, let's examine one of the worst, lateral soil movement, or LSM. When treating or preparing to treat a structure for subterranean termites using subsoil injections of any termite product, it is critical to determine if the structure's water system operates on a groundwater well system. If the structure is on a well, the risk of contaminating that well with termiticide is significant. Worse yet, you could contaminate the entire aquifer, the water table deep in the ground that may supply many homes with their drinking water. You need to understand how the well works and is constructed to better grasp this and mitigate the risk of it happening to you or the company. Drilling rigs bore deep into the ground until they reach an underground aquifer. A pipe is installed to draw the water out, and this pipe is encased in gravel all the way from the water to the pump head. Another pipe channels the water from the pump head to a holding tank or filter to supply the house. The well lines are encased in gravel, which acts as a French drain, meaning any fluid can freely migrate through the encasement. The fact that LSM allows termiticide to move through the ground creates a high risk of termiticide entering the entire water system. You, the inspector or the technician, are responsible for identifying whether the structure is connected to a well system or public water. On the next slide, we will examine how to identify such issues, what must be recorded, and what the product label allows and requires for treatment in these cases. To avoid that type of catastrophe, you must follow 4 rules. First, locate the wellhead in the yard. They will look similar to the photos on this slide. Second, in the structure, no matter what type of structure, as any of them could be on a well, locate the pressure tank. That will normally be accompanied by filters or even water softener equipment. Third, and critical, locate and pinpoint where the water lines enter the house. The next slide we will explain why that is important and point out why this is the 4th step. The product label and the Department of Agriculture require you locate the wellhead and locate it on the treatment graph. You're also required to locate where it enters the structure and list the linear feet between structure and well. You are to draw a line from wellhead to structure to show what areas are to be avoided, or to use the trench and backfill method. The trench and backfill method for termite control involves digging a trench by the foundation, treating the excavated soil with a termiticide, and then refilling the trench with the treated soil. No ground rotting or pressurized application in that area. This is done to determine the linear footage either side of the well line. Refer to the product label for exact directions and footage required for this method. This is done to prevent the termiticide from entering the gravel and leaching to the wellhead. If the wellhead is too close to the house or in the house, do not treat unless you communicate with your supervisor. You have now completed the video training part of basic structure training for new hires in the pest industry. Please proceed to the exam part, and good luck.